Now we have the final panel, which will digest what we've heard today and analyze that. Shravan will moderate, and we have with us Jerry again, hopefully now with a somewhat better connection, Peter from HiUV, and now also live with us, Tristan from Canada, where he's working for PVEL. Welcome to all of you. Shravan, please take over.
Thank you, Michael.
Hello,
dear
sorry.
Panelists. Yeah. Jerry, you are online?
Yeah, sorry. I have a problem with my background, so I have to communicate with everyone by microphone. Sorry.
That's fine. So, yeah.
But otherwise, if the background doesn't work, just take another one. So it would be nice if we can see you. It would be nice. If not, okay. Shravan, just go ahead.
Yeah. Okay. So I don't see if Tristan has joined.
Yeah, I'm here.
Oh, okay, great. Hello, dear panelists. Again, so we all met during the prep calls, but again, I would like to welcome you to this panel to discuss how to ensure reliability for modules with high efficiency cell architectures. So, reflecting a little bit on the conference side, usually polymer wraps, be it backsheets or encapsulation materials, they're considered to be the backbone of a module reliability. So that is why, we also have a greater representation from these materials in our conference. So now it's really clear that the PV industry is all set to move beyond PERC. A year ago, there was, of course, some ambiguity, but now I think it is very clear the first step is going to be TOPCon because of the cost and also the simplicity side. And even some companies have also moved to heterojunction. So while the bulk is really continuing under research. So JA is one good example for this. The company has really commercialized TOPCon, but still working on heterojunction in the background. So let's first focus on the reliability of the TOPCon modules. Tristan, you have shown that the reliability with any new technology is somewhat loose at the beginning, but then it eventually evolves. So, what are the loose ends with the TOPCon technology you found or you expect? Can you shed some light on that?
Yeah, sure. Good question. So I didn't present on this topic specifically in this presentation, but I have on other presentations. We do see quite a range in the TOPCon modules we've tested, particularly for damp heat and PID. The previous two presentations that I was able to watch here obviously had a focus on PID resistance or susceptibility of TOPCon modules. At least the previous presentation didn't state anything about damp heat, but we've seen, some really good damp heat results from TOPCon and some, frankly, incredibly poor TOPCon results for damp heat. And, I think those cells are just, I read in a paper once that TOPCon cells are more delicate than PERC. And that really caught my eye, that they're more delicate. There's more layers. There's more that can go wrong with moisture ingress and PID. So, as I said, we've seen some examples where TOPCon modules perform very similar to PERC. We've seen other examples where something in the cell, and we don't know exactly what, led to really high damp heat degradation and PID degradation. So I think that's where the industry needs to focus. Likely, it's also a choice of what encapsulant was used, as well as what's happening on the cell level.
Ah, okay. So then what about the learnings that we have made in the past, for example, with technologies like PERC? So you have already shown that that the MBB technology kind of, it was kind of, now we are mature. So do you think, do we have to repeat the same exercise, or some of these learnings can already be implemented into the TOPCon?
I'm pretty skeptical. I think we do have to repeat those learnings. I think, PVEL, going back to, our founding, we've seen many examples. And in this presentation, I showed, how multi-bus bar over time gets better for thermal cycling results. But I could have used, a dozen different examples showing that new technology is introduced. There's some manufacturers and some bill of materials that do well and some that don't do well. And over time, our hope and what we typically see is eventually they all do well. But then once they're all doing well, that's when a new technology is introduced and we start the process again. I don't think we've seen, hopefully over time that process shrinks, and instead of 4 or 5 years for stability, it's 2 or 3. I don't know if the solar industry is going to ever hit 0 years for stability, where as soon as a new technology is released, it's immediately reliable. I'm just skeptical on that. I hope that's the case, but we haven't seen it yet in our history.
Okay. All right. So Peter, what are the challenges actually in designing an encapsulation material for TOPCon? So I think you reflected a little bit on your presentation. Can you go a little bit into the details?
Yeah, actually, what we found is similar with the Tristan from PVEL. Yes, the TOPCon cell have much more complicated layers compared with the PERC. And based on the reliability data, yes, the DH and the PID is much more challenged compared with the PERC. So that's why we say the POE field actually is very good, reliable material, but we need to solve or improve the module process defect for the pure POE. And why we introduced the EXP is also the reason we can solve the module process defect, and also we can reduce the POE reason. And for the TOPCon technology itself, what we observe is we think because it's quite new technology. So currently the cell technology is still have much difference between the cell makers. So they have the different technology to do the coating, and it will affect at the module level. Something like we use the same encapsulation film for different cell makers TOPCon cell, and we will get some totally different results. So this is also a different situation compared with the PERC. As you know, the PERC is totally very, is for many years. So everybody knows the structure and everybody actually use the almost the same process. Yeah.
Okay, so Jerry, do you really agree with what just Peter and Tristan said?
Okay, the about experts give great answers. Yeah.
Okay.
I think, sorry.
Yeah, please go ahead.
Based on the, from my point, based on the structure, process, and characteristics of TOPCon cell, compared with PERC products, I think there are two main differences. Yeah, first, the selection and optimization of encapsulation materials. PID degradation of PERC cell mainly occurs on the back side of the cell, while PID degradation of TOPCon cell mainly occurs on the front side of front side of the cell. Therefore, POE, per POE or EPE film with higher volume resist resistivity should be selected for encapsulation materials. Second, in order to reduce the consumption of silver paste, TOPCon cell usually adopts SMBB technology. So it is necessary to optimize and adjust the welding process to improve the welding precision. Of course, more retail TOPCon cell is also a must, just like the fail pass of my presentation earlier. That's all. Thank you.
Okay, thank you. So, let's talk a little bit about the supply chain issues. Now, actually, there is a serious discussion about short supply of POE, especially for TOPCon modules. Peter, you might be really aware of this. A lot of people are talking. So just now, Dow also kind of not really said that, there is enough, but probably it's enough. We don't know yet. So Tristan, will it going to impact the reliability, based on your experiences from the past? So when such supply chain constraints hit the segment?
I would say short answer is yes. I don't know specifically on, the TOPCon POE topic, but, we've always seen, again, over our history of testing, extended reliability testing of over 10 years, that, small changes in the bill of materials impacts reliability. And that doesn't always mean it negatively impacts it, but that is the risk. And when manufacturers are changing encapsulants and changing cell types and cell recipes and other materials because of material shortages, those changes need to be proven. And that's, the service we provide. And that's why we care so deeply about the bill of materials in our testing. That's why we send third-party auditors to see what materials were used, and we get a record of those materials, because those materials and that combination has been proven. If you want to change it, you need to complete retests. Our hope would be that those changes lead to the same level of reliability, but that's not always the case.
Okay, so Peter, how are you going to tackle such situations? Because I think end of the day, you are the ones, who has to face the client, a pressure from the module maker, and short supply from the resin supplier. So how do you plan to address such situations? Now there is already an alarm in the industry.
Firstly, I would say actually the reasons supply should be depend on the downstream, the module installation consumption. So actually, why everybody say next year maybe have some limitation for the reason is based on the module installation forecast. So the installation forecast is also impacted by the policy or something like the silicon price. So I would say it's have many factors to impact this. So if it is real very high installation volume by next year, yes, the PVE resin maybe is limited at certain time. So that's why we also prepared the new product called EXP to reduce the POE resin. Actually, our module customer also realized this. So that's why they are also concerned about the risk for the supply chain risk. So they are trying to use the EXP fuel. Yes.
Okay. All right. And Jerry, so what would be the solutions from your side? What are the alternates you are thinking for such a situation?
Okay. In this case, the supply of POE fuel may be insufficient In order to cope with this situation, JA Solar will continue to develop and verify the different structure film for different modules, and reduce the use of POE on the premise of ensuring reliability and product quality. So as to meet the quality control requirements of primary manufacturers and customers. In my opinion, this is actually an issue of quality control and cost control. Pure POE and POE has better reliability, but the preparation process needs to be further optimized. EPE and EPE has a faster laminating speed and may have abnormal bubbles. JA Solar has determined the different solutions for different types of modules through verification. That's all.
Okay. Actually, I think we have very little time. But before I ask the final question, I would like to ask one question to Tristan. What's right now, as you might have seen, CPC is really becoming the main, is becoming a larger backsheet configuration in the market, is actually leading with about 50% market share. So how do you see the reliability of CPC-based products? Just a summary, if you have already worked on it.
I think we have tested some bombs using CPC, and I think in those cases, I don't recall, any poor performers there. I need to double check the data. Of course, I don't have it in front of me. I think mostly what we've tested, of course, are backsheets based on films. I've either PVF or PVDF or PET films. I know that in past roles in my career, I've audited backsheet manufacturers that were using CPC, and I think getting consistency in the coating was always a challenge. And I know when, in module production, we were able to scratch off those coatings as the module was going through the production line. And that was always a concern. This is a few years ago, so I don't know if those concerns have been fully addressed or not. So in short, I think it does present some reliability risks while probably solving other issues. And again, if the material has been vetted and the suppliers have been vetted, it should be fine. But you need to do your due diligence.
Okay, so then I have one final question on the recyclability. No matter how reliable a module, at some point the life gonna end, and so just I would like to touch on this topic of reliability once. So the currently volumes are low, but at some point the amounts will be really huge. So how have we prepared? So are we prepared for this topic? At PVEL, are you focusing by any chance on this lanes?
We're not looking at it specifically yet. I mean, we're supportive of the actions by companies like SolarCycle in the US and others around the globe on increasing the awareness of recyclability and getting those facilities up and running. I would say that on the topic of reliability, the longer these modules will last, the less we need to recycle them, and the bigger our impact to climate change. If we can get to 40 or 50-year module lifetimes, there's going to be less modules that need to be recycled. There's also going to be less modules that need to be produced because we're meeting our energy needs with the modules we made 40 or 50 years ago than needing to replace those. So I think, you know, to kind of turn the question, PVEL providing, you know, reliability data to the industry and confidence in module lifetimes, you know, a secondary or tertiary effect of that is there's going to be higher reliability and a lower need for recycling, although we do respect that need will eventually be there. And I think it's important to make sure that these millions or billions of modules avoid the landfills.
Okay, so Peter, would you like to comment from the encapsulation material supplier end?
For this part, I think we are always follow up with the module makers. So actually, we already mentioned, we are triggered by the cell technology. So for us, we are always open and flexible to meet our customers' requirements.
Okay. And Jerry, do you want to add any final comment on this?
Okay, the recyclability of PV module is a very good topic as the market continues to increase in 20 years later. I think there will be a lot of decommissioning of the modules and more. JA Solar has also made some research on module recycling and participated in the preparation of some standards. As for the whether recycling can be considered away from the product set in advance, it is certainly necessary. Let me give you an example, such as the adoption of fluorine-free backsheet, which is a very good direction. But in this process, we need to repeatedly verify the reliability performance of the product. I also believe that with the efforts of everyone, we can solve this problem. Thank you.
Okay, great. I think that's a very nice conclusion that we should all look towards recyclability, and of course, using high reliability, we can extend this period where a module needs recycling. So with this closing remarks, Michael, I would like to hand over the session to you.
Okay, great, thanks. And while I maybe do the closing remarks, if you have still a few minutes, just answer some of the questions. I think there's still a lot in the chat, so maybe you can do that multitasking while you're also listening to me. Again, thanks a lot first to the panelists. I think that was a great conclusion. Thanks to the audience that stayed with us for our last event. Thanks to our sponsors who made that possible. Thanks to the great TaiyangNews team who also made that possible. And let me just quickly summarize what my takeaways were here. Let me just share this screen. Oops, 1 second. I think you can see it, right? Okay, cool. Yeah. So, yeah, just I just want to summarize what we learned today. So first we had PVEL, Tristan talking about how technologies get better in reliability over time in general. There's no guarantee though, so thorough testing is needed. And as he just repeated during the panel when he was asked for CPC, do your due diligence when things come bigger to the market and you had different experience with them in the past. In any case, we had Fraunhofer also kind of drumming the same beat. Intensive testing is a must. They showed different measures how to test. Importance is really in increasing with the market getting more dynamic as simply new type of products, back sheets are entering the market, as we're also now seeing, obviously, also new cells increasingly hitting the market. It was great to have Longi, which really showed actually in this interesting corporate presentation how important they take reliability, and that really the most progressive and leading manufacturers are really looking at it from every angle, and that reliability is the base for a comprehensive life cycle view. And this also includes then recycling and even carbon footprint, with Longi being part of RE100, like a few others in this sector as well. It was also good to have JA, another leading module manufacturer, which pointed at their recent TOPCon technology, which they're introducing, and that module reliability has improved with new encapsulation structures using EPE, maintaining the POE film thickness at 150 microns and adapting to thinner ribbons. It was good to hear from Jollywood, the world's leading backsheet manufacturer, that the trend is toward CPC, very informative, now with a share of over 50%. They also showed transparent backsheets with and without grid as new products. We had with HiUV, a leading encapsulation producer, expanding quickly and reaching 100 gigawatt of capacity by end of this year. HJT and TOPCon have complete different passivation layers, as I mentioned, as well as metallization and structure. And for that reason, they need also different encapsulation solutions. They came up with a couple of new proposals and products. EXP is one of these new solutions from the company for TOPCon, and they have UV light conversion films for HJT. Cybrid, both so a leading or the second largest backsheet manufacturer and also active in the encapsulation field, also mentioned how important transparent backsheet passing sequential reliability testing is needed. They also showed reflective black backsheets and fluorine-free as other topics. It was really interesting also how they emphasized the move to going fluorine-free for backsheets, although even that's mostly limited still to Europe because of regulations. And they also pointed to UV conversion films as a highlight for HJT. The presentations were finalized by Dow, which presented the first time for us. Dow is the world's leading supplier of POE, and they made a strong and convincing product pitch for their high quality POE that has reliability advantages over EVA, e.g. improving PID resistance. I think the LCOE calculations were also positive. Everyone has to do it for him or herself. But in any case, it was very interesting. That's it from my side. Once again, thanks to everyone and hope to see you next year. We will start in January with another event where we sort of create a highlight of our recent high efficiency cell conference, which took place last year. And where we more or less give an outlook on cell technologies for the next year. For this year still to come is the backsheet and encapsulation report. We will just put in the information we learned today, and then it's ready to go, hopefully before Christmas. And then we're back in January. Thanks again for staying with us over the year and for this conference, and have a nice day or a nice evening. Thanks again. Bye-bye.